Welcome to a discussion on magnetic effect of current and ensued by a discussion on power generators. Before we go deep into this, we have to understand what a magnet is. Magnet, that which exerts an attractive force, is called a magnet. Anything which attracts some materials is called a magnet. A magnet is a material that produces a field that attracts or repels other such materials of magnetic nature. Lodestone is a naturally occurring magnet. It attracts materials like iron, nickel, cobalt, etc. Two things we have to understand before we go deep into this discussion is current. One terminology is current, another one is magnetic effect. Let's have a quick look into the definition of these things. An electric current is a flow of electric charge in a circuit. Current means electric current here. And you can see the picture of a cell, and from the negative pole of the cell, the electrons flows, and it goes through, in this picture, through the filament of a bulb, producing a form of energy called light, and it returns to the positive pole. This is a simple circuit with light. Well, we'll look into what magnetic effect is. Magnetic effect of electric current is, a magnetic field is a vector field that describes the magnetic influence on moving electric charges, electric currents, and magnetized material. A magnetic material will have a magnetic field. A flow of current will exert a magnetic field around its conductor. A magnetic field, we'll repeat, is a vector field that describes the magnetic influence on moving electric charges, electric currents, and magnetized materials. A magnetized material will have a magnetic field. A flow of current will exert a magnetic field around its conductor. Thus, we understood that a magnet, when subjected to a field of electric current, causes it to move. This movement is called deflection. Power produces movement is one simple factor we gain from this experiment and these facts. Let us see some of the properties of a magnet. A free suspended magnet always points towards north and south direction. The pole of a magnet which points towards north direction is called north pole or north seeking. The pole of a magnet which points towards south direction is called south pole or south seeking. Like poles of a magnet repel each other, while unlike poles of magnet attract each other. Similar to other effects, electric current also produces magnetic effect. When a magnetic material is brought into the field of a force of an electric current, it will interact and will exert some changes. These changes will cause some displacements or deflections. We can see the compass needle will move to one side. The needle deflects when it's brought near a coil or wire through which electricity passes. This shows electric current produces magnetic effect, and it can produce kinesis. A current carrying straight conductor has magnetic field in the form of concentric circles. You can see around the pole in blue colors there are concentric circles. This shows the magnetic field, the path of the magnetic field. The magnetic field of current carrying straight conductor can be shown by magnetic field lines. That's what you see in blue lines here. The direction of magnetic field through a current carrying conductor depends upon the direction of flow of electric current. It is depending on the direction of flow of electric current. The direction of magnetic field gets reversed if this flow is reversed. So it is dependent on the direction of the flow of electric current. Let a current carrying conductor be suspended vertically and electric current is flowing from south to north. In this case, the direction of magnetic field will be anti-clockwise. If the current is flowing from north to south, the direction of magnetic field will be clockwise. The direction of magnetic field in relation to the direction of the electric current through a straight conductor can be depicted by using the right-hand thumb rule. We explain the direction rule with a rule called right-hand thumb rule. It's also known as Maxwell's corkscrew rule. If a current-carrying conductor is held by the right hand, keeping the thumb straight and in the direction of the electric current, the direction of the thumb is in the electric current, then the direction of wrapping fingers will show the direction of magnetic field. That is a simple rule. You can see, hold your hand around the wire with the thumb pointing towards the flow of current direction, and then the magnetic field will be from here to here in the same direction of the wrapping forefingers. Maxwell's corkscrew rule: if the direction of forward movement of screw shows the direction of current, then the direction of rotation of screw shows the direction of magnetic field. You can see experimented with a screw. If the point towards the direction of the current, then the way you turn the screw to tighten it up is in the direction of the magnetic field it exerts. We'll see some of the properties of magnetic field. The magnitude of magnetic field increases with increase in electric current. That means when we increase the supply of current, the magnetic field also will increase, and it decreases when you decrease the supply of electric current. The magnitude of magnetic field produced by electric current decreases with increase in distance. As you take away, the field becomes weaker and weaker. So distance is an important factor, and the activity is vice versa. When you close it, it increases. The size of concentric circles of magnetic fields lines increases with distance from the conductor, which shows that magnetic field decreases with its distance. Magnetic field lines are always parallel to each other. They are parallel to each other. Okay, and magnetic field lines always parallel to each other. No two field lines can cross each other. It's not possible. This principle is very important in the manufacturing principle of generators, motors, etc. No two fields can cross each other. A movement of a magnet within the field of a coil can produce power. Of course, that's an important factor. A movement of a magnet within the field, because of this, no two field can cross, it produces power. Mechanical energy can be converted to electric energy, and electric energy can be converted back into mechanical energy also because of this principle. And that is made use in manufacturing a generator. The working principle of generator is based on this principle.